Now we'll be talking about ergonomic studies and their use with object printers. Ergonomic studies is really quite a challenging solution. Actually, today, CAD software solutions don't have a good offering when it comes to ergonomic studies. Creating a prototype and placing it in its environment, in a virtual space, in a software solution, is a challenge that is difficult to master. Naturally, 3D printing, and in particular Objet, come very strong at hand here as a solution when it comes to ergonomic studies. You have your prototype, you print your prototype, and then you place that prototype in its working environment to see how the person, the user of that prototype, fits into its environment. Now, Objet has a very strong solution here, mainly because of our ability to print beautiful parts, fine details, very much resembling the end product, and also our ability to print rubber-like materials. In addition to that, we have what we call Connex solutions, Connex machines. And those Connex machines allow for different rubber-like materials to be tested at different shore levels to really simulate the end product. So ergonomic studies and Objet really have a very nicely knit solution.
Loomis offers eyewear that is natural-looking, discreet, lightweight, and portable. It permits users to watch TV, read an email, or glance at stock tickers without anyone else knowing they are doing this. The term ergonomics is derived from the Greek words ergon, which means work, and nomos, which means natural laws, and is concerned with the fit between people and their technological tools and environments. It takes account of the user's capabilities and limitations in seeking to ensure that tasks, equipment, information, and the environment suit each other. During the development stages of the new generation Loomis eyewear, extensive use of the Connex was undertaken by the engineering and design departments at Loomis, an i2D design firm. The challenges were to make the design eye-catching and appealing while incorporating the optical and electrical components into the frame and maintaining the highest level possible of ergonomic comfort. In terms of ergonomic comfort, 4 key elements were taken under consideration: the size, weight, nose pad support, and temple arm support. To determine the size of the new frame design, 2 basic design approaches were undertaken. Once the CAD design was ready, several prints of all parts were done using the Vero Gray material. The glasses were then assembled together and decisions were taken on the final design size and shape. The weight of the Loomis eyeglasses is considerably heavier compared to regular glasses due to the optical and electronic devices that are incorporated into the frame. This means that the designers needed to make a unique nose pad and temple arms to support the weight and maintain ergonomic comfort. A common nose pad supports the weight of the eyeglasses at 2 points on the nose. Loomis designers tried a new concept to support the weight using a nose piece that has full contact with the nose arch, thus distributing the weight on a larger surface. Numerous designs using different shore values were printed using digital materials combining Vero White and Tango Black Plus. Transparent Tango Plus material with shore A value of 27 was also used to check a nose pad design that incorporates aluminum pieces that can be hand-formed to check different shapes. Temple arm pads were also printed in various digital materials from shore A27 to 85 and were assembled over the Vero Gray frame parts. All combinations of the different nose pad designs and temple arm pads were assembled together with the printed frame, electronics, and optics and tested on different people with different facial structure to ensure that the chosen design would fit perfectly on the majority of users. The ability to print fast and accurate models in both rigid and flexible materials that can be used for functional and ergonomics tests accelerated the development process and increased the company's confidence in its new product. To sum it up, the Loomis story is an excellent example of the use of 3D printing to ensure ergonomic comfort in products early in their design stages.